All right, we're back. We're still on page 200. We're just doing some practice problems. Nothing really new, but since we kind of know what we're doing now, we can move a little more quickly and just reinforce some ideas and see some ideas again. The more you look at this stuff, the better off you are. We're gonna try to make everything happen in GeoGebra as usual. Maybe use a calculator, probably, because this one looks like it's got some algebraic stuff that I probably don't want to do by hand. Let's see the situation. So we have A, B, C, and D. That's a lot of points. Particle travels from A to B in 18 minutes. Write parametric equations. All right, we're going to say this is particle 1. Particle 1, and therefore x1, y1. So you're starting at A, so 110. And then, all right, A to B. So you're going to add 8 to x. So plus 8, but it takes 18 minutes. And then what do you do to y? You lose 6. So minus 6, but it takes 18 minutes to do that. So this will only be valid between 0 and 18. All right, not bad. Next, another particle moves along a straight line from C to D, okay? Where on the coordinate plane do the two paths cross? All right, so I have some choices at this point. I could just do algebra, right? Just write the equation of this line, write the equation of this line, solve the system of equations. That's a definite option. Another option is to just like fake another set of parametric equations, which is what I'm going to do. I'm going to call this particle 3 because particle 3 is kind of fake. Or is it? Yeah, I mean, we just don't know enough. Particle 2 is going to take like the real problem into consideration. Particle 3, which I'm just going to make up, I'm just going to say it takes 1 minute from C to D. And that means that I can write parametric equations for that. So that's going to be, I'm going to write them up here and then move them, I think. Well, maybe not. So x3, y3. So we're going from C to D. So 0, 4 is the point C. And then it's just going to be plus 13t and then plus 4t. And this will go between 0 and 1. So why is it useful to have particle 3? It's useful because particle 3 and particle 1 are also, like, no matter what the actual context of the problem is, particle 3 and particle 1 are going to do the same thing that particle 2 and particle 1 do. Like, their paths are going to cross. It's going to be at certain times. Particle 3 doesn't really matter, but the time that particle 1 gets to the intersection point is going to be the same no matter what particle it's going against, like if this is a race or whatever. So I'm going to use particle 3 to figure out both the intersection point and how long particle 1 takes to get there. So I'm going to do a system. I'm going to do the dummy variable system. So system, I'm also going to use a calculator for it. I'm going to do x1 of t1 equals x3 of t3, and then y1 of t1 equals y3 of t3. And so T3 doesn't really mean much in the context of the problem, other than it kind of will tell you, depending on what information we get out of this, it kind of will tell you when the actual particle 2 gets there. If you remember, we like already did a problem like this, and I kind of use the fact that like time to intersection over total time should equal time to intersection over total time for anything that's moving at a constant speed along this line segment. So let's go to the calculator, let the calculator do it, and then we'll like potentially talk more about that. So I'm gonna do a new problem, graph page. I always go to graph page because it's the easiest way to enter the parametric equations so that we can then use them on the calculator page. So I gotta put in 1 plus 8 over 18t. Sometimes I use a template there and sometimes I don't. I'm sure you have noticed. 6 over, you gotta be the same, 18t. And this should go from 0 to 18. Just, I'm not sure they actually intersect. Sometimes I don't write the best problems here. And also, like, I've never done these problems before. This is the first time ever. So I want this to actually be 3. So can I not get to 3 without putting something in 2? Oh, no, I can. Okay. So this is 13t. And then this is 4 plus 4t. So this is an experience for me also. I've never done these problems before. They're interesting problems. I like them. All right, these definitely do, the paths do intersect. So now I'm going to add a calculator page, and I'm going to solve the system, menu 3.7, two equations, two unknowns, T1 and T3 for me. If on the handheld, if you just use normal X and Y, that's totally fine. Just like keep track of what each variable means. So I need to do X1 of T1 equals X3 of T3, and Y1 of T1 equals Y3 of T3. Okay, so T1 is actually the time that particle 1 gets to the intersection point. T3 is actually the time that particle 3 gets there. It's just that particle 3 is like made up. Like it doesn't really matter. So, so T1 is 666 over 55. Okay, so I'm writing these in the notes right now. So T1, 666 over 55, and T3 is 27 over 55. Both over 55, that's kind of interesting. Now to find the actual intersection point, x1 of t, comma, y1 of t, such that t equals 666 over 55. And then you can like confirm, it's gonna be right, but it's gonna be right if you do it right. If you enter something wrong, you're gonna get the wrong thing here, and then you get to think more, and that's not a bad thing. So the intersection point is gonna be, I'm just writing it in right now. The intersection point is 351 over 55, comma, 328 over 55. This is going to be really hard to get GeoGebra to show us like the exact thing, I think. And then we also now know, so let me go back to the notes, and I can show you what I wrote, although, I mean, pretty sure you figured it out. All right, so while you were gone, I wrote down the times, specifically these. So remember, T1, that's legit. T3 is like for our convenience. We decided to make up a particle that just takes 1 minute, which is what I pretty much always will do. And then the intersection point, I used T1 in these equations, and I checked T3 in these equations. Both of them gave me this. This is the intersection point. By solving the problem this way, we also figured out when particle 1, so particle 1 is at the intersection, oh my God, at the intersection at t equals 666 over 55 minutes. Okay, so I think that what we can do is we can use the fact. So what's the next question? Assuming both particles are going to start at t equals 0, they both reach the intersection at the same time. So that means that particle 2, the real particle moving from C to D, gets to the intersection at 666 over 55. I think we can use some proportional reasoning. I think we can say that since they're going at a constant rate and they are, what am I saying here? They're going at a constant rate, they're moving on the same line segment. So like P3 to intersection over P3 total should be equal to P2 to the intersection over P2 total. So this is how I'm going to choose to solve this time. There's a lot of ways you can solve this. We solved it other ways. So I'll solve it a different way on the calculator also, but I'm not going to write it out. So particle 3 to the intersection was 27 over 55, right? Which we got from here. And particle 3 took an entirety of 1. And then particle 2 to the intersection is 666 over 55. And then this is going to be P2 total. So we just need to solve that. Actually, I think you can solve that pretty easily. I think that's just P2 total is 666 over 27, which like definitely reduces because they're both multiples of 3. Does it reduce more than that? That's 222 over 9. I don't think that reduces. No, 222 is definitely a multiple of 3. I don't know. I don't want to reduce that. I'll use a calculator to do that in a second. So I think that that's going to be the total. Let's go to the calculator and just solve this in two different ways. So I'm going to confirm my answer, maybe. So I solved 27 over 55 over 1 equals 666 over 55 over, I'm just going to say like P. And I solve for P. And then is that the same as 666 over 27? It is. Okay, so I'm going to add that to the notes. So P2 takes 74 over 3 minutes. Okay, the other way we could do this is we could create a set of equations for x2 and y2. So remember, that's going from C to D. So you start at 0, and then you gain 13 over, let's say, an amount we don't know. I'm going to call it P times T. And then here you start at 4, and you add 4 over P. So now P is the unknown amount of time that it takes particle 2 to make this journey. And now what I think I can do, I don't want to create, I actually don't even want to graph it. So cancel, don't do that. I'm going to go to the calculator page. I can like solve this the way that I usually solve these. Menu 3.7, system of equations. There's going to be two unknowns. The two unknowns are what? I don't know. T and P. T is the time and P. Yeah, okay. So this works because they get to the intersection at the same time. So I'm going to do x1 of T actually just equals x2 of T because they get to the intersection at the same time. That's why this works. Y2 of T. I'm going to solve for T and P. T is the time at which they both get to the intersection. P is the total amount of time it takes particle 2 to do its job, which hopefully is 74 over 3. And it is. So that's another effective way of doing this. Should we try to make GeoGebra do this? I think so. I'm going to switch to GeoGebra. If you don't want to, you know, you can turn this off. But usually this is when I find out that I did the problem wrong. So your mileage may vary. All right, let's see. So this is the wrong thing. I meant to share GeoGebra. All right, classic. Again, I don't know how I'm going to get. Oh, you know what I'll do? I'll just like set it up and then I'll just like type in the amount. This shows up sometimes. I always just delete it. All right, so I'm putting particle 1, x, oh, no, curve. What am I doing? Why is this in parentheses? Curve, there we go. 1 plus 8 over 18, 18t, 10 minus 6 over 18, t, 0 to 18. Okay, where is that? It's out here, all right. Now, I didn't ever actually write the parametrics for particle 2, so I'm doing it on the fly here, but I'm basically just going to modify what I did for x3, y3. So 0 plus 13 over, should be over 74 over 3. And then t, comma, 4 plus 4 over 74 over 3, t. T goes from 0 to 74 over 3. Okay, let's see. If I do b of 0, it should give me 0, 4, which should be the starting point. If I do b of 74 over 3, it should give me 13, 8. 74 over 3, 13, 8. Yes. Okay, so this is working. And then I'm going to put points on both of them. So I'm going to do a of v. It'll make a slider. I'm going to do b of v. And it makes a slider. I need to go from what to what? 0 to, which one's bigger, 18 or 74 over 3 is definitely bigger. So 74 over 3 is like an annoying number. Well, it's 74 over 3. Step size, I don't think it matters. I'm going to modify. So which one? The one that only takes 18 is this. So I'm going to make this the minimum of v and 18, just so it stops and doesn't look stupid. Let's go, right? So here, you can see they look like they're on track. Boom, get there at the same basic time. Let me just click here and type in I don't know what it's going to do, 666 over 55, because that's when they get there. There, and you can see they have the exact same coordinates at that time. So we totally did it. All right. Good job, I guess. Let's go back to the notes. It says to draw the whole thing, but I mean, we use GeoGebra. So I'm gonna write it on GeoGebra because that's what the cool kids are doing. All right, so that's it. I will be back in the next video. Keep going on this page, so I will see you there.